saw limits in your summer packet a lot. So let's go ahead nicely. Well, some of you will actually be frustrated by this. Technically, section 1.2 does not deal with, we can keep that, does not deal with limits analytically, aka it does not deal with limits algebraically. Now, on some of these ones, if you guys are using tables or are using graphs, you can possibly double check using what you know of factoring and canceling out and be like, okay, is it the answer? I think it should be. But I need you to deal with them numerically and graphically with tables and with graphs, okay? It's crucial. Please just trust me. What are some important words that are up on the screen? Honors, you especially should know this. Regular, you saw it a little bit last year. Arbitrarily close to a single number, which means a constant, right? To a single number. And what word is repeated? Approaches, right? That's a key word of limits. Approaches. We have x approaching, we have an independent variable approaching, and then we are looking at what the heights are doing or what the y's are doing. So the answer to any limit problem, if it exists, is a height or a y value, right? It's a height or a y value, a function value. The limit to any, the answer to any limit problem, if it exists, is a height or a y value. How do we know which one? Well, we have to approach the correct x value. Like the videos in our summer packet, the little drivers going to the diner, right? Can I keep going? Remember, real quick. So, last year, without going, you don't have to put it in your notes. But for those of you guys that weren't here last year, I love some of these illustrations of limits. Oh, I still have my typo in there, though. Struggle. For instance, how long does the decimal equivalent to 1/6 go? Forever. But what quantity is that infinite decimal? One number, 1/6. One constant encapsulates the forever decimal that we can never totally write down. Does that make sense? So it's kind of like the limit of this repeating decimal is the constant 1/6. MC Escher, I like him. Can anybody explain from last year why does that somewhat illustrate a limit?
It approaches arbitrarily.
As you get arbitrarily close to the boundary, you have infinitely many fishes. There are little fins and little eyes and little rats here. Okay, never mind. Fractals! Still kind of confined in an infinite space with in a finite space and infinite perimeter. Interesting. So we gotta keep going. Fractals is like this really cool Nova program on them, and like, I don't know, they made CGI possible. And I think it was this first Star Wars. The one where the lava is like falling on the platform, that was made possible by fractals. So we gotta keep going.
That was the third one. Yeah,
Star Wars.
The third one is the original one? I meant the first one, like the first set. I apologize, my Star Wars fanatics that are like, I know exactly what scene you're talking about. Finding limits numerically with tables. With tables. We know tables and how they work. This one is horizontal. You could also have vertical, but usually we're going to be dealing with horizontal. It's what the AP does, so I'm trying to get you used to it. X values go on top, Y values go on bottom. You examine what the Y's, what the heights, what the function values are doing as X becomes closer and closer. We're trying to mimic, we're trying to get arbitrarily close in some senses to the number it's approaching. So if I have a limit as X approaches A of f of X, and I'm trying to look for it, A would be in some senses if I'm writing it down in the middle. But I'm trying to approach A. So I'm going to approach A from below, with different X values that get closer and closer, from above, different X values that get closer and closer. And I'm trying to ask myself the question, as I plug in X values getting closer and closer from below, and plug in X values closer and closer from above, what y value, if possible, what single y value is the function approaching from below and above. So for instance, if I was to take the function right below, do I have it? I think I do. Let's say I was to plug this into my calculator. Okay? Now, I know it's a vertical table instead of a horizontal. Do you see me approaching -1? Uh-huh. Now some of you are like, wait a minute, but you plugged in -1. Oh, the calculator. Can you guys tell what I actually did? I had 1 0, I had 2 zeros. What did I do next? 3 zeros, but what happens? My calculator has to round it. If I was to scroll up in my calculator, this would actually be, and I should have left it on that one, 1.0001, and this would be 4.0001. So I'm still approaching, but as I come from below, my heights seem to be approaching -4, especially since it rounded it. And as I come from above, what do my heights also seem to be approaching? -4. So I can say, based on my experimentation, all appearances point to the limit being -4. And you guys know from summer, how can you double check that you're actually right? Factor, cancel out, plug it in. Guess what? It's -4. Okay? But in a table, numerically, how does it appear you can approach? Now, really quickly, for those of you that are like, how'd you get all those weird numbers? I thought tables went by like set units. I don't have it up there. Those of you guys that remember, what do we need to do with our table setup to allow us to type in whatever number we want?
Second window.
Second window. Window helps us with the graph. Second window helps us with a table. And normally tables do go by ones. Right? 0, 1, 2, 3, 4, 5. But we can change that. And we could go by point ones, but that still wouldn't help us go by many different decimal places. So instead we would go to ask instead of automatic. Take away the automatic generation of the table. Then it's just going to be a nice blank table, and we can plug in whatever we want. Now, guys, I don't have the function in my y equals, so nothing's going to happen. But we can type in whatever x values we want and get out the appropriate y values once we plug it in. Second window, make independent ask. Okay? So then if we were to do this one, the limit as x goes to 0, sine of 3x over x. We would plug in, are you in radian mode? We would plug in sine of 3x all over x. Your second window table setup, remember, would be on ask. Question, how can we simulate, delete this one, I don't want that one anymore. How can we get closer and closer to 0 from below? -0.01. That's getting pretty stinking close. How do we get even closer? -0.001, right? How do we get even close? Wait, You got to negative? Well, you got to 3? No, but we're getting closer, right? Okay. Now, what if we were to come from, we could try plugging in 0, guess what? Doesn't work. Why? Look at it, you can't plug it in. But you do get 0 over 0, which means keep going, which means there might be an answer. How do I come from the other direction? Well, actually, I like being really close. Sorry, it's my whole symmetry. Minded mine. And then 0.01. And as we look, as we get in closer and closer, kiddos, man, what does that limit seem to be? 3. But there's an error at 0. I don't care. What's it approaching? 3. You're like, I see a 3 in there. Yeah, that's a thing. We'll talk about it. Not today. But that is a thing for sine of something over x. Graphically, here's where we're going to end today. It's the second half of the section, graphically. the exact same thing that we do on the table, approaching a certain x value from below and from above. We can say from the left and from the right, or the right and the left. We're looking at the y values still, but we're literally looking at the graphs. And so without even knowing exactly what function this is, if I was to label this f of x, and if I was to ask you to fill in the question based on the graph, the limit as x approaches 1 of f of x is, how would you respond? Some of you are still writing, that's totally fine. So let's go ahead and remember my whole, it's easier to listen fast than to write fast. So let's drop our pencils. You know where this is saved, shared folder, class notes, let's just listen. As x approaches 1, from below and above, as the two little dudes in their cars are going towards the diner, are they headed to the same place? And what height is that at? So the limit is, but there's a hole! Wait, summer packet. Oh, it's okay, it just did what? Burned down. You're going to have to choose somewhere else to go later. But for right now, are you meeting at the same place? Yes. Or as actually our book says, it's like you get there, you get up to the building, you try to get in, and the door is locked, nobody is home. You can't get in, but you're there. So then with graphically, don't write. The one thing we need to remember, as you come towards a set constant, just focus on this last one. This is the overall limit, not the one-sided. Obviously, we have a little more work to do tomorrow, but what is the limit as x approaches c in this graph? Does not exist, or the AP might say non-existent. Why? Because the one-sided limits do not agree. 1, 2, 3, 4, 5, 6, 7. Technically, no. Kiddos, I want you to get going on section 1-2 homework. It won't be due until Monday? Today's Thursday. I have a few more notes to take tomorrow. See you guys later.